To stay updated, subscribe to TJ Academy.
Bismillahirrahmanirrahim. In this video, we are going to discuss Johansen Cointegration. First, the main assumption of Johansen Cointegration is all variables dependent and independent are stationary at first difference or I1. Johansen Cointegration use two type of statistics. Number one, trace statistics, and number two, maximum eigenvalue statistics. Hypothesis of Johansen test is there is no cointegration if trace value is greater than its critical value. It means reject H naught, which shows there is co-integration. The same is for eigenvalue. If maximum eigenvalue is greater than its critical value, it means reject H naught, which shows there is co-integration. Now the procedure. First, select all variables. First variable should be dependent. Step number 2, open these variables as group. Number 3, go to view and select Johansen Cointegration. The main advantage of Johansen Cointegration over angle Granger cointegration is that angle Granger cointegration identify only one cointegrating equation. On the other side, Johansen cointegration can identify more than one cointegrating relationship. Now we are moving towards the procedure. The first select all variable, first should be the dependent one. Here we have the model where GDP is the dependent variable and labor force, capital and FDI are independent variables. Then step 2, open these variables as group. So right click, open as group. This is the group. The third one, go to view and select Johansen Cointegration, view cointegration test, then Johansen system cointegration. Right. Now we are looking at this window. One more way to get this is here, go to quick, then group statistics, then Johansen cointegration test. Here you will have to write some variable like this. If you select all variable like this, so they appeared here, GDP, labor force, capital and FDI. First variable should be the dependent one. Then if we apply press OK, then we will get the same window. Now we have to select two things here. One from these 5 options and the leg length. Basically, what are the assumptions? How can we select these assumptions about deterministic trend? So here are the summary. Johansen cointegration assumption of deterministic trend. Now these are the options 1, 2, 3, 4, 5. If all variable, the level data have no deterministic trend and the cointegrating equation do not have intercept. If you see your variable follow this assumption, you have to select the option number 1. Same here. If your data says this one, that the level data have no deterministic trend and the cointegrating equation have intercept, so you have to adopt the option 2. Mostly in time series data, 3 and 4 would be appropriate. The level data have linear trend, but the cointegrating equation have only intercept. The level data and the cointegrating equation have linear trend. And there is an option number 5, the level data have quadratic trend and cointegrating equation have linear trend. So if first we have to identify which assumption is better for our data. But if you are not confirmed about the assumption, so we should use the summary option. This summary option will tell us which option is better with the appropriate leg length. So I repeat the procedure. First, select the dependent variable, then all independent variable, then right click open as group. This is the group window. Go to view, co-integration test, Johansen system co-integration. If I'm not sure about the condition of the data, we have to select the summary to find the appropriate option and appropriate leg length, then press OK. So this is the window. Here you can see this one, option number 1, option number 2, option number 3, 4, and similarly 5. And here is the archaic information criteria and Shaw's information criteria. You can use any one of them. So if we follow the Shaw's criteria, there is a static one. This shows 1, 2, 3, 4, option number 4 and leg 1 is appropriate one. This is static shows option number 4, 1, 2, 3, 4, and this value show the number of leg. The leg 1 with option 4 is an appropriate in our model. So I should go to view, co-integration test, Johansen system co-integration. We have to select option 4. There is already a leg 1. If the answer would be 2, so we have to write here 2, but we know here is the appropriate leg length is 1, so we have to write 1 here. So we have selected our option number 4 and leg 1, then press OK. So this is the result of Johansen cointegration. There are two tables, trace and maximum eigenvalue. These are the value of trace statistics and its critical values, and these are the value of maximum eigenvalue statistics, and here it's the critical value. Now none means there is one co-integrating vector, which is your equation in which your dependent variable is GDP. Here at most one means if this variable is significant like this, the trace statistics is greater than the critical value, it means reject H0. You can see here. If trace value is greater than its critical value, it means reject H0, which shows there is co-integration. So here 65.56 the trace value and its critical value is 63.87. It means trace value is greater than its critical value, means reject H0. It shows there is co-integrating equation. But on the other value, at most 1, 32 is the trace and 42 is the critical value, it means there is no co-integration. What does it mean? If only the none is significant, it shows there is only one co-integrating equation. Similarly, the maximum eigenvalue shows the value is 32.72 and the critical value is 32.11. So at none means at one co-integrating vector, we have to reject a null hypothesis, which shows there is co-integration. But on the at most one, 21.43 and 25.82, here the maximum eigenvalue is less than the critical value, so at most one there is no co-integration. So none shows the significant result, which shows there is a one co-integrating equation only. If this would be significant, it means two co-integration. If this would be significant, it means three co-integration. So both test, trace and eigenvalue statistics shows there is one co-integrating equation. There is one co-integrating equation. If trace and eigenvalue show different result. In that case trace is more appropriate. References of this one are given in description. So this is the interpretation of Johansen Cointegration. One more thing, when we scroll down, so here the normalized cointegrating coefficient, the value having the variable having below the value 1, which means this is the dependent variable, same as we have selected, and these are the independent variables like labor force, capital and FDI. Here labor force, capital and FDI, what we have to interpret that the sign would be opposite. Let's suppose there is a minus 2.02 is the normalized coefficient of labor force. It is not a minus 2, it would be a 0.029. The coefficient of capital is 0.487. The coefficient of FDI is 0.106. We have to take the opposite sign. If the labor force shows a negative value, it means it has a positive effect on GDP. Same here, the capital shows a positive effect on GDP. Here the negative sign, it means FDI also shows a positive effect on GDP. But these are the standard errors. If we divide these coefficients with standard error, we will get our T statistics. The T statistics will show whether these variables are significant or insignificant. So in this case, these are the normalized cointegrating coefficients. So if you want to report it then OLS, then it would be better. So in this case, these are the interpretation of Johansen Cointegration. I hope this video will help you to understand how to apply Johansen Cointegration EViews. If it is so like the video, share and subscribe my channel TJ Academy.